Hello everyone, this is Dr. M. Venkateswara, Assistant Professor, Department of PC, Pace Institute of Technology and Sciences. Today, I am going to take about session about CST Microwave Studio. I have taken how to design a rectangular patch antenna in this session. So, first of all, I will take a patch antenna dimensions. Later, I will demonstrate how to design that patch antenna in the CST Microwave Studio. So, if you see here, this is a rectangular patch antenna of dimensions 40 by 40 mm, and it is having a patch of 20 mm both width and length, and it is also having feed of length 15 mm as well as width of length 3 mm. So now I am going to CST Microwave Studio scenarios. So CST is a widely used antenna designing software where you can design n types of antennas. So if you go for CST templates, there are so many templates are there. So whether it is micro and RF, whether it is EDA, whether it is EMI, EMC, or it is low frequency components, or a charged dynamics. It is widely used in electronics, electrical as well as mechanical sectors. So today my aim is to design a rectangular patch antenna using CST Microwave Studio. So for that I have taken micro and RF optical things. So here again the CST Microwave Studio is very particular about what is the sector you need to take. If you go for antennas, if you need to select this antenna template. If you go for circuit simulations, you need to go for circuit and component simulations. If you are going for radar cross section scenarios, or else biomedical SAR scenarios, or else periodic structures, there are predefined templates available in the CST Microwave Studio. So now I want to design an antenna, so I have selected the antenna template and then I look into the antenna template. So there are again different types of antennas. If you see here, there are waveguide type of antennas such as horn antennas and cone antennas, etc. Planar antennas, wired antennas, phased arrays, mobile phones, reflectors, dielectric resonators and RFID chips. So I need to design a patch antenna, so that I am selecting the planar template. So next I will give the boundaries, the time domain or else frequency domain. So like that I will close this scenario and I will go to the complete dialog box of a CST Microwave Studio. This is how a typical CST microwave window will be. So in this we need to select n number of things. So suppose if you consider the scenario of what we need to design. So the box, white color box is the substrate material. The blue color boxes, first one is on the top side it is patch, and the downside it is feed line. So I need to design this patch, I need to design this substrate, I need to design this feed line, and I need to give the source, and then I need to run this in the CST Microwave Studio. So opening to this, CST Microwave Studio has a tremendous advantage that it is user friendly. So if you go here in the modeling section, if you observe here the modeling section, home, modeling, simulation, post processing and view. While modeling I need to go for modeling section. So first of all I will select a brick and then I will select escape, so that a dialog box will be appearing. So in this dialog box I need to give the dimensions of a substrate. So first of all I am naming it as substrate. Later I will be giving the dimensions with respect to variables. Suppose width of the feed, I will be terming it as WS, width of the substrate. So I am starting from the center of symmetry, that means the half side will be starting here and it will be ending here. So the length of the substrate and width of the substrate will be projected here, and the important thing we need to do in this here is to assign a material. The column which material assignment, here we need to assign a material. So what we will do is we will select a material, we will load it from a library, we will select FR4 material, we will search where the FR4 material is present, and then we will load this one. So now we can see before it is vacuum here, now it is FR4 material. So click on OK. Immediately it will ask the dimensions. Only variables I have given. Width of the substrate, I have given the variable WS. Length of the substrate, I have given the variable LS. Now I am giving the dimensions. For both, I am giving 40 mm. WS is 40 mm and LS is 40 mm, and it is having a thickness of 1.6 mm. H is 1.6 mm. So you can see how it is varied. So the substrate has been designed here. You can observe in the screen that the substrate has been designed. Now I need to take a feed line and also I need to attach a patch to that feed line. So before that, I once again remind you what is the dimensions of the feed line. The feed line dimensions are width 3 mm, length is 15 mm. So again, going to CST software, it has a beautiful advantage that if you press M, it will be highlighted at exactly at the middle point, and then you can align the WCS here. That means you will be assigning the axis exactly at the center. It will be very useful to give center of symmetric properties. So now what I will do is I will take a brick, then again escape. I will name it as feed line U minus WF by 2, WF in the sense width of the feed, and then it is starting from 0, so that 0 to LF. So again it will ask you what type of material. It is PEC, perfect electric conductor, PEC material. So now I will go for preview. It will ask what is the WF value. I will give the value 3. Width of the feed line as mentioned earlier, it is 3, and then LF as mentioned earlier, it is 15. So you can see the imaginary feed line here. If you confirm it, it will be static. So you can observe here that the feed line has been created in this studio, CST Microwave Studio. So now I want to design a patch which is above the feed line. So now what I am taking is, again I am selecting M, I am selecting it, I am assigning the WCS, and then I am giving patch. I will name it as patch, and again WP by 2, WP by 2, and then 0 to LP, and the material is PEC. So now I am going to put the dimensions 20 mm for both, and I can see the imaginary figure here. So patch is of 20 mm. So then I will confirm it as OK. So immediately what I will do is I will select the control, feed line and patch, and then I will select the feed line and then add boolean and then add patch. If you observe before, there is a small line between feed line and patch. Now what I am doing is I am attaching both. So feed line, boolean, add, and then patch, enter. Okay. So the feed line and patch has been created. A small correction which will be added, we will be creating the ground itself. So we will be creating some limited ground, a partial ground. So again I am selecting P. One thing you need to remember is to select the middle point, you need to take M. If you want to select the edge point, you need to take P. So P, align WCS, and then take brick and then name it as ground, 0 to 40, and then height is 12 mm. So you can observe here, the ground has been created on the either side of the either side of the substrate. So you can see while rotating, the field line and patch is on the top side and the ground is on the back side. So the rectangular patch antenna having partial ground has been created. Now the only thing left is to give the port here. So now what we will do is, we will be giving the port. Now I will select P for both the edges of the field line. You can observe here. So now what I will do is, I will go to the simulation view. I will take a waveguide port. There are different types of ports we can give to the rectangular patch antenna. You can give waveguide port, you can give discrete port, you can give plane wave port and lumped element port. Every port has its own advantage. Everything has its own advantage. I will take waveguide port because it is a antenna which is having field line and patch on the top side and ground on the back side. So I will take the waveguide port. It will ask you to put the dimensions. So what I will do is, I will take the width of the substrate, thickness of the substrate I will be taking, and I will multiplying with some constant. Let that constant be K. K into H, K into H, K into H, K into H. That constant H, K will be 2. You can see now how the port is assigned. It is confidently accessing both the ground plane as well as the top plane. So now what I will do is, I will click on OK. So I will rotate for a better view. I will zoom it. You can see all these things, how it is confined to this. The port is confined to this particular antenna. Now the design of rectangular patch antenna has been completed. Now I am analyzing this rectangular patch antenna. So what I will do is, I will go for setup solver here. I will click on that setup solver, and then it will ask me which frequency range do you want to simulate. I will give from 1 to 20 and then click on OK, and then it will ask you to start or not. I will tell start. If you observe here, the simulations is running here. Each mesh analysis will be running fluently, and the results will be obtained on the left side of here. So if you observe one by one after simulation, this results will increase. You can observe now it is 2 results. If the simulation goes on, those results will be increased. The S parameters, VSWR, Z parameters, impedances, or power, all these parameters will be increased on the left side of the CST Microwave Studio. Okay. So now that you can observe some results has been added. You can see how it is varied. Though the simulation is not completed, we can verify some of the S11 parameters. Right. Now that simulation has been completed, and this particular project file will be saved in your laptop, and all the results, if you observe here, all the results, VSWR, impedances, all the results has been here. So now one by one, how we will retract the results, we will see now. So first and foremost thing, reflection coefficient S11. So below minus 10 dB, you can term as working region. So you can observe here where it is working. The first point which I have marked is at 2.5. The second point which I have marked is at 5.2. So from 2.5 to 5.2, the band is working by using this designed parameters. Okay. So like that, similarly, the VSWR values, the impedance values, everything you can see, even the port mode characteristics, the far field results, all those things can be seen. So in this CST Microwave Studio, we can also see the time domain signals. So which is most equal whenever we will give the input signal, how much it is transmitted, that is also we can observe in the CST Microwave Studio. So I hope all of you can understand this very well. So this is a basic antenna to design. This session will be very much useful for the beginners, and there is lots of scope to design many more antennas which will be used for navigation purpose, DRDOs, national laboratories, etc. And almost students have great opportunities by learning this particular CST Microwave Studio to design antennas. So I hope all of you understand. Thank you all.